Hi guys, today I'm going to demonstrate you the type of the Ellipse MC type in the chapter of inequality from the equation of straight line. Hkdse 2019 paper 2 question number 23 is one of the problem that only having comparing the only equation straight line in the graph. So always step 0, you should make the y as a subject so that you look for the y-intercept and also m for the slope as well for comparing those inequality. Step 1, make y as a subject. ax plus by plus 15 equals to 0, y equals to negative a over b, x minus 15b. M as a slope so that we can see negative a over b will be the slope. And what about y-intercept? Y-intercept will be negative 15 over b. So we can mark it in the graph directly. This point for y-intercept, that will be negative 15 over b. Okay, so step 1, we can compare the y-intercept by 3 here, so that we can compare with 3 and this y-intercept. Comparing the magnitude, 3 is larger than negative 15 over b actually. Okay, and then we are going to swap the b to the other side so that it will be 3b and then negative 15. But the point is, if we are trying to times b, we need to determine whether b is a positive number or a negative number first. Okay, so in this whole idea, negative 15b over b is a positive number. How come? Because it is above the x-axis, it is for the positive number for y, so that it will be the whole number be positive. Okay, and if the whole number equals to positive, b has to be a negative, so that negative number, so that it will be okay for a negative 15 divided by a negative number. Negative times negative will be positive. Okay, so if we are trying to times b, then it means a negative number. Then we need to swap our sign from larger to a smaller sign. Okay, then next step, b will be smaller than negative 15 over 3, that will be negative 5. So for part 3, that will be incorrect already. Well, at this point, we can circle answer will be A. Okay, that is by comparing our y-intercept. Comparing the with 3, and also it will be a positive intercept, y-intercept as well, be a positive number because it is above the x-axis. Okay, step 2, we can compare the x-intercept. So for x-intercept, we can input y when y equals to 0. In order to look for the x-intercept when y equals to 0, ax plus 0 plus 15 equals to 0, so that x actually will be negative 15 over a. Okay, if it is negative 15 over a, then we can mark it here, negative 15 over a. Same case, we can determine the a would be positive value or negative value. Negative 15a, it is at the left side of the x-axis, right? And then it means it will be a positive value as well. Okay, so the whole thing will be equal to a positive value. Then what about a? Negative 15 divided by what to be a positive number? Yeah, that would be a negative number as well, because negative divided by negative would be positive. Okay, a is a negative number. Then what about comparing with 5? If we compare with 5, then negative 15 over a, this whole value, is larger than 5 here by comparing their magnitude. So larger than 5. What about if I swap the a to the other side? I try to times a. Negative 15 something, larger or smaller, 5a. Yep, we need to change the sign because a is a negative number. Change the larger to a smaller sign. Alright, if it's smaller sign, then a will be larger than negative 3 at the end. So number 2, it is correct. Most tricky part, that will be the last one, number 1. A, compare A and B. The only scenario we can see the A and B will be having negative A over B would be their slope. Okay, so the last part we are going to compare the slope. Okay, so normally if I make it bigger here, we can compare for having a positive number, positive slope, negative slope for going down, and then we can compare their magnitude as well. So the less inclined slope will be 3, for example, more inclined would be 5. If it's going down, so going down is negative 3, going down crazily, then we have negative 5 here, etc. So we can compare their magnitude. But in this case, we have only one line, and we have a negative slope obviously for going down. But are we going to compare with 0 only? If we have smaller than 0, so we can make the negative A over B, the slope, smaller than 0. If we swap the B to the other side, we are still comparing A with 0. In this case, I am not going to use this method, but I am going to compare another number 1 here, or actually negative 1 for going down for negative slope. So if I have 2 points, that would be xy intercept would be 3 and 3. This slope actually would be negative 1. Then what about if I have another line that is here, having less incline? And what about the slope? This slope will be lessly inclined, right? Then it means I can compare the slope with negative 1, and in this case it will be larger than negative 1. The reason why is, for example, if this one is negative 1 and I have lessly inclined, for example, maybe this one will be negative 0.5 to be smaller magnitude for 0.5, but a whole number. Negative 0.5 is still larger than negative 1, so that my slope here will be negative A over B will be larger than negative 1. Okay, in this scenario, I am comparing with another number, 3 and 3 here. So I'm comparing with this line, this point is 3, and this slope would be negative 1. I am having this slope, my original slope, that would be negative A over B. By comparing with the slope, negative 1, I am having a larger slope than that. Okay, next step, swap the B to the other side. I'm going to times B. Times B, so negative A something negative B. So I try to times B. B is a negative number again. By previous, I look for B is a negative number, so that it will be change it from a larger side to a smaller side. One more step, what about I try to times negative 1 for both sides. A and B can be compared. I don't copy the sign. I change the smaller to larger this case because I times a negative number. So at the end, number 1 is correct by having A larger than B. Okay, so at the end, let me conclude one more time. I was using y-intercept for the first comparison, and then I'm using x-intercept for comparison. And the last step for the slope, since I have only one slope, I am comparing my imaginary line for having the slope equals to negative 1. I have less inclined slope so that my slope will be larger than negative 1, like negative 0.5 or negative 0.3, etc. Okay, so I am having the last information by comparing A and B for 3 following steps: x, y-intercept, and the slope for the final conclusion.